So this is the information you're going to want to know to analyze a curve or find the behavior of a curve in certain intervals. So the first thing is, if f prime of x is 0, and f prime of x basically means the first derivative of f of x. So if it's greater than 0, then f of x, the original function, is increasing. Now if f prime of x vice versa is less than 0, then f of x is decreasing. Now if it's 0, if f prime of x is 0 or undefined, then it's a candidate for a maximum minimum point, and we can't tell certainly what it is until we find how the graph acts from the left or right, and we use a sign diagram, and we'll do some examples with that. And moving on with the second derivative, f double prime of x, if that's greater than 0, then f of x is concaved up. And concaved up basically means, like, if you look at the graph of x squared, it's kind of like a smiley face, so it's concaved up. And f double prime of x is less than 0, which means that f of x is concave down. So if you look at negative x squared, it's kind of like a frowny face, it's going down. And if f double prime of x equals 0, it's a point of inflection, which means that this is the point where the concavity changes from either going up to down or down to up. Okay, question 1 we have, if f of x equals 2x cubed plus 3x squared minus 36x, find the intervals where f is increasing or decreasing, the local maximum or minimum values, the intervals of concavity, and the points of inflection. So to find all this, we obviously need the first derivative and the second derivative equations. So f of x, we have 2x cubed plus 3x squared minus 36x. And the derivative of this would be, we could just use power rule for each term, 6x squared plus 6x minus 36. And now we need to set this equal to 0 in order to find the maximum minimum values and where the function is increasing or decreasing. So first we can just divide everything by 6, and then we'll have x squared plus x minus 6 equals 0. And if you factor this out, you'll get x plus 3 times x minus 2 equals 0. And now if you solve for x, you'll get x equals negative 3 and 2. And now we can make a sign diagram with these two values. And this is the sign diagram of f prime of x, the first derivative graph. So negative 3 and 2 are what we're going to put because that's what x equals. And if you plug a value, anything to the left of negative 3, so if you plug in negative 4, it's going to be a positive value. And if you plug in a value in between negative 3 and 2, so like 0, you'll have a negative value. And if you plug in a value greater than 2, so 3, you'll get a positive value. So now we know where the function is increasing or decreasing, as positive indicates an increase and a negative sign indicates a decrease. So we can just put arrows here to show that, and an up arrow. Okay, so the function is increasing in the intervals negative infinity to negative 3, union. And the union just means that there's a break in between the curve from 2 to infinity. And then it's decreasing from negative 3 and 2. And this is where the function is increasing or decreasing. And now if we want to find where the function has a maximum or minimum, all we have to do is look at how the behavior of the function changes in between this interval. So here we see the function is increasing until it gets to 0, and then it decreases. So that's going to look like this. And here, the function is decreasing until it gets to 0, and then it increases again. So it's going to look like this. So our maximum point is going to be at negative 3. X equals negative 3. And our minimum point is going to be at x equals 2. As it just shown here, this is the highest point in this interval and the lowest point. Now let's find our points of inflection and the intervals of concavity. To do that, we need to have the second derivative graph. And to do that, we need to just derive the first derivative graph. So f double prime of x equals 12x plus 6. And to find it, once again, we need to set this equal to 0. And now if we just solve for x, we're just going to have x equals negative 1 over 2. And now if we make a sign diagram of the second derivative, we will have this to be negative 1 over 2. And if you plug in a value less than negative 1 over 2, you'll have a negative number. And if you plug in a value above negative 1 over 2, you'll have a positive. So now we see our intervals of concavity. So here the concavity is going to be down because it's negative, and here the concavity is going to be up because it's positive. So I'll just abbreviate concavity up with C up from negative 1 over 2 to infinity, and I'll abbreviate concavity down with just CD, and that's going to be from negative infinity to negative 1 over 2. And right here is our point of inflection, because here is where the concavity changes, which is the definition of the point of inflection. And I'll just abbreviate that with POI, which is at x equals negative 1 over 2. And now we have everything that we need. We have our intervals of where the function is increasing, decreasing, our points of where f of x has a maximum or minimum. We have our intervals where f of x is concave up or concave down, and we also have our point of inflection. So we can just box in our answers right here. Question 2 we have, if f of x equals x squared over x squared minus 1, find the intervals where f is increasing or decreasing, the local maximum or minimum values, the intervals of concavity, and the points of inflection. So we're going to do the exact same process, but this time we have a rational expression, a rational equation. So first, we're going to find the derivative. So we have to do the quotient rule. And now if we simplify this, we'll end up having negative 2x over x squared minus 1 squared equals 0. And now if we solve for the zeros, and remember, it doesn't just have to be 0, it can also be undefined. So x, if we solve for the top, it's going to be equal to 0. And if we solve for the bottom, this is just going to be 1 and negative 1. Now we can put these values on the sign diagram. So we have three values, negative 1, 0, and 1. Now, if you put a number less than negative 1, so like negative 2, this is going to be a positive number. And if you plug in a number between negative 1 and 0, this is also going to be positive. And in both of these, it's going to be negative and negative. So here, and also this is the sign diagram of f prime of x. So now we can put our increasing and decreasing intervals. So we can see that it's increasing from negative infinity to negative 1 union negative 1 to 0. And the reason we don't include negative 1 and 0 is because at negative 1, the function is not increasing or decreasing, it's just 0. There's a horizontal tangent line at that point. So we don't say it's increasing or decreasing. And then it's decreasing from the intervals 0 to 1 union 1 to infinity. And here, we can see that there's only one maximum or minimum point, and it's going to be right here, because here, the function is increasing, and here it doesn't decrease, it keeps increasing, and only at x equals 0 is where the function actually changes, so it goes from increasing, and then it goes to decreasing. So we can just say that there's a max at x equals 0. Now let's find the values of the intervals of concavity and the points of inflection. So now we need to find the derivative of the first derivative, which is the second derivative. So 6x squared plus 2 divided by x squared minus 1 cubed. And now we're going to set this equal to 0. And now if we solve for x on the top and bottom in this second derivative graph, we'll have x squared equal to negative 1 over 3. But obviously you can't square root a negative number because you'll get imaginary. So we'll say there's no x values for the top, which is the numerator. So let's find anything on the bottom. So here we actually can solve for x. We'll have x equals 1 and negative 1. So in our second derivative sign diagram, we're going to have two values to put, which is going to be negative 1 and 1. Now, if you plug in a number less than negative 1, you're going to get a positive number here. And if you plug in a number in between negative 1 and 0, you'll get negative. And if you plug in a number greater than 1, you'll have a positive number. So now we have our intervals of concavity, which is just going to be C up between negative infinity to negative 1 and union 1 to infinity. C down is going to be between negative 1 to 1. And then our point of inflection is going to be at x equals negative 1 and 1, because this is where the concavity changes from going up to down and then going back up. So now we have all our details once again. Our intervals of where fx is increasing and decreasing, our max point, and here there's no midpoint. And here we have our intervals of concavity where it's going up or down, and we also have our point of inflection, so we can box in all of our answers.